Welcome to my final project presentation by Frank Palmisano. My application is a currency conversion application. For my project, it will have the ability to compare exchange rates against numerous countries at once. Also, it will have the ability to save notes about certain countries selected relating to current exchange rates. In addition to this, the application, when a certain country is selected, will display a map view of where the country is. Now we're going to look at the MVC diagram. So we'll start at the view. On the left here, we can see the view, which displays cells in a list table that we've previously seen on my application. It displays all the buttons and features, displays the country rates, it displays the map, and displays the notes view for entering notes. Above this and to the right, we can see the controller. Controller contains the table view model. It also contains the notes NS object that will be stored in core data, contains responses to all buttons, contains responses to all web service API calls, and contains retrieval of core data. Also controls the notes object in core data. So the relationship between the two, view and controller, is view has the ability to update variable values in the controller. Also, it updates values for actionable items such as buttons, segues, and maps. The controller in this case updates changes for labels, cells, and other UI items, provides a reaction, and changes of the UI based on input that is stored in the controller. Now let's look at the model. The model is on the bottom right here. The model contains the core data of what is being stored, as we saw before when we were changing these values. Let's look at how model influences a controller. So model has the ability to send commands to manipulate data in the model to be controlled by the controller, which in turn can update the view based on those new models and inputs. The model also receives and initializes data using getter and setter methods in the controller. Now let's look at the relationship between controller and model. The controller updates and controls the variable values and behavior. So this is if we store an object, say we're storing a string value into notes, and we want to save that for later use, it will store that in the model, and the model will control how that is stored. Also, the controller manipulates data to be controlled or to be initiated by the controller. Next, let's look at my class diagram for my project. The class diagram here is made up of three parts. So we have the view controller class, the country table view controller, and the NS object notes model, which is stored in core data. The view controller class is what we're seeing right here on the right on the iPhone itself. So contains all the labels for the countries and the labels for the conversion rates. Also, we can see that it contains the text view for notes to be entered and then saved into core data. We can see here at the bottom that we have a map view. The map view uses the current country as input and then stores a longitude and latitude to be received by an API of maps that is at Apple and retrieves that information to be accurately displayed on the map below. This may look like an easy task, but it was interesting to figure out how to implement this based on a selection from a table view, which is shown back here. See, if we were to select Canada, it would bring up the Canada view and show Canada in the map. Also, as we see here, it would display all the conversion rates. So let's go back to Australia. As we can see, purchase €2 tomorrow is still saved, which is an accurate representation of how core data works and how it was correctly implemented. Also, in the map, you can see that the label Australia is clearly defined. So let's go back to the list. And now in the list, this is the country table view controller. So the country table view controller controls this list here. It has the UI table view. Also, it contains an array of the symbols for exchange rates as well as an array for the country name. These functions here are standard in order to control the list and which it segues to. At the bottom function here, prepare, this is where we send data to the next controller, view controller, that loads all data that is relevant to the previous selection. On the bottom here, we have our NSObject notes model. Our notes model contains the country as in a string and any notes that were entered in as a string as well. Whenever we store any notes, it will be stored in the note text object here as a string, and then brought up later whenever we need to go back. The country is saved as well to reference the note text that is being accessed. This is important and almost acts like a dictionary. The capabilities of my project are using web APIs such as the one shown here to retrieve exchange rate information. Also, my application has the capability of using core data to store users' notes that were relevant to the current country that was selected. As well as this, it uses the MK-MapView delegate to mark on a MK-MapView the current country selected by using Apple's server resource as an API for retrieving coordinates using forward geolocating. The limitations of my project are very limited. The application is able to retrieve currency exchange rates to only a select number of countries. Not every single country is included in the list that the API returns when it is called asynchronously. Also, the amount of notes is restricted to the maximum allowable data allocation by core data in the persistent object store. There were many lessons learned while making this application. The following are this. During the creation of my application, I was successfully able to learn the following frameworks and Swift modules. I was able to use core data to implement storage for offline use and also retrieval use for quitting the app and then rejoining the app and having data being loaded and displayed on screen. As well as this, I used MapView, which is the MK-MapView delegate. The delegate allows me to display a map and also edit where things appear on a map, including pins, names, and other information. The map view was helpful because it had many different methods to use in order to achieve the goal. Also, interfacing with third-party and Apple-based web APIs was important, and it taught me a lot about how to use software as a service to implement functionality within an application that can be done off application and in a different geological location than using it on the application itself, saving resources but not saving time. Using a web-based API includes latency time from server to the device. And finally, these are my suggestions for improvements for the class and project. To enhance the learning material in the course, I would suggest having a separate lab section in order to provide assistance to students that either do not have an Apple computer or need additional help with the material. Assigning labs to do in class and at home is time-consuming and would rather be done in a class setting with a proctor available to help with any questions that any student may have had. Also, Swift is a generally new object-oriented language. More time familiarizing students with the language could foster an improved interest in new programming languages and also make students learn about cutting-edge technologies. This would make students more approachable, hireable, and desirable amongst many companies in the market.